Hello everyone, welcome back to Module 3, Part 4 of System Verilog Interfaces and Verification Examples. We'll now understand the different test bench components in System Verilog. The diagram which is shown here explains the different components. So it includes typically a generator. This is the generator component of System Verilog, followed with uh, the driver. So the generator sends transactions to the driver via mailbox. So there is a mailbox between generator and the driver. So via mailbox, the transactions are sent, which are nothing but the packets of information. They are sent to the driver. At the driver, the packets are given to the DUT from driver to the DUT via interface. Now, interface is that layer wherein the packets or the transactions are converted into binary data and then given to DUT. The DUT is wherein we have written the RTL code for a particular design, that is the RTL design which we have written in Verilog. And the DUT then outputs its result, which is again in binary, to the monitor via interface again. So that's in binary format. So monitor then converts this into transactions or packets again and gives it to the scoreboard. So we have a mailbox here again, wherein we put the packets, which is given by the DUT. And that is then sent to the scoreboard. So we have mailboxes between driver and generator. There is a mailbox between scoreboard and monitor. This is the mailbox. So the function of the mailbox is to put the packets to the driver here, or put the packet from the monitor to the scoreboard here. So that's the function of mailbox. And we have interface here, which is between monitor and DUT. This is the interface connection. And we have interface between driver and DUT also. So this is the interface again. This is what is the test bench environment of a typical system Verilog. Let's see an example. And of course, this entire thing is called as environment of the test bench. So that is shown here as ENV. And the outer space of the environment is called as test bench. For example, I'm taking a very large program here to make you understand like how we have to integrate all these components and do verification for our DUT. So our DUT here is, we are trying to write a DUT for a adder, which is a 4-bit adder. So we have, so this is our DUT actually. So we have the module by name adder, and 4-bit A, 4-bit B, and 5-bit sum we have considered. And we are using continuous assignment to calculate this expression, to find out this expression, which is assign sum is A plus B. So we have A and B. It's combinational circuit design, and we have sum here. So this is a 4-bit A, this is again a 4-bit B, and the output is 5-bit. And we are using assign statement to evaluate this equation. So it's assign sum is equal to A plus B. So this is the DUT. Now we also, let's start the understanding how we are building this test bench environment for this DUT. Okay. So later, of course, the top module is also written, which invokes this, the top module is also written, which invokes this adder and interface. So we have adder, interface, and the test bench entirely is invoked. But before understanding this part of the module, let's understand how we write each of these components of test bench. So DUT is, I think it's clear. So let's go to the transaction class. What transaction class does is it gives us the packets, and these packets are given to the generator, and from the generator they are given to the driver via mailbox. So that's what happens. So since I want DUT for 4-bit inputs A and B. So I'm taking inputs as RAND rand, randomizing it. So rand bit of 3 down to 0, A comma B. So this is what my packet variables are. So class transaction, then 4-bit A comma B, which is randomized. I'm using rand declaration here. And then the output is a 5-bit. So bit 4 down to 0 sum. So this is the transaction data, which is nothing but the entire packet which is being sent to the sent through the generator to the driver via mailbox. Then I'll be converting the port declarations into interface. So we have understood how interface is defined. So it's interface followed with interface name. So adder underscore if is the name which we have given, and we are declaring all the port declarations here. So it's A and B. We have A, B, and sum for this DUT. So A, B, and logic. We don't mention the directions in the interface. We just mention the data and the data type. So it's logic of 3 down to 0, A comma B, logic of 4 down to 0, sum. So this is the bundle which I have formed by using with, or which I have constructed using the syntax interface. And the name of that bundle is adder underscore if. So once the transaction and interface are done, let's now write all the components of the test bench. To start, we'll start with driver component. So the function of driver is to, so if you see the diagram back, here is the driver. So this is the driver. So the driver takes the input from the mailbox and gives it to the DUT through the interface. So on either side of driver, we have mailbox and the interface. So that's the reason we define inside driver a mailbox, interface, and a mailbox as follows. It's shown here. So we have interface, we have mailbox. Okay, so we make it virtual. The reason being, interface is between classes and the DUT. So it's talking from dynamic environment to a static environment. So when that is the condition, that is the state, interface on the class side should be made dynamic in nature, and that is done by using the keyword virtual. Okay, so virtual and then the interface adder underscore if, that's the interface, and the instance of that is VIF. That is what has been defined here. And then the mailbox. So mailbox, I'm naming it as Gen2 DRV because it's between generator and driver. And what is mailbox sending us? It's sending this transaction, this packet, which is nothing but the transaction packet. So I have to mention it in the mailbox syntax as hash of transaction. So that's the syntax you have to mention. So what mailbox carries and what is the name of the mailbox, that is the syntax to be mentioned. Then inside the driver, I'm declaring a task which does, wherein I'm creating an object of transaction. So by saying transaction tr, and then in a infinite loop, I'm taking the packet from the mailbox. So it is gen to drv. Gen to drv is the mailbox. So get the packet from gen to drv, that is the mailbox, get it from there. And what are you getting from the mailbox? The packet tr, so of tr. So that's the syntax. Then you'll be writing that into the interface. So it's vif dot a equal to tr dot a, vif dot b is equal to tr dot b, right? So we are writing that packet from the mailbox into the interface. So that is what is being done here. And every time I wait for a time period of 5 time units so that the data gets stabilized there. So that's as simple. That is the way we write driver. So what is the function of driver? Takes data, takes the packets. Data is in the form of packets from the mailbox and puts it into the interface. So the mailbox takes the packets from the transaction. So that's the reason we put hash of transaction there. Okay, so that's about the driver. Then let's see what is monitor. So class monitor, if you go back to the monitor here, see monitor has on one side interface, and on the other side it has again the mailbox, right? So this is the mailbox and this is the interface, and on in between interface and mailbox is the monitor. So you have to declare in monitor class also interface and mailbox. So interface and mailbox we have declared. Again virtual because I'm in the class environment, so because it's dynamic in nature, you have to make the interface as virtual. And mailbox name is mon to scb. I'm writing it as mon to scb because mailbox is between monitor and scoreboard. And what is it again doing? Mailbox is writing the packet which is being which it gets from the DUT, right? So hash of transaction again. Okay. Then where are you writing it? You're writing it from the interface into the, you're receiving, right? You're receiving the data from the interface, and you're putting it back as a packet, converting it into a packet. That's the reason in the infinite loop you create an object of type transaction, and you save the data into this object which you get from the interface. So tr.a equal to vif dot a, tr.b is equal to vif dot b, correct? Because I have monitor here. So this side I have interface, and on the other side I have mailbox. Mailbox is taking the packet, which is TR, correct? So from here to here, you're transferring the data. The binary is getting converted into packet, into transaction packet. So that is what we are doing here. We are creating the packet of transaction type, and we are loading that packet with the interface data. So that is what is being done. And monitor also gets the output because DUT calculates the expression, evaluates the expression, right? That which is assigned sum is equal to a plus b. So that sum is also being written into the transaction. So tr.sum is vif.sum. So that you write, you put it into the, that packet is put into the mailbox, which is this mailbox. What is the name given to it? Monitor to scoreboard. So monitor to scoreboard dot put, will do dot put of tr and enter. So that is about the monitor part of the test bench. Then we do the scoreboard. Now scoreboard just sees whether the evaluation done by the monitor by the DUT is correct or not. For some of the test cases, the evaluations are tested. So I have class scoreboard. Scoreboard actually on this interacts with the mailbox. So you need to define only the mailbox. See, we have scoreboard here. This is the scoreboard, and it is having a mailbox on its one side. So that's the reason we have in our scoreboard, we have scoreboard and the mailbox defined, only the mailbox is defined. Then inside the task run, we generate a object of that transaction, and in the infinite loop from the main box I get the object, correct? So mon to scb dot get of tr, because mail already I have written the packet into the mailbox. Who has written? Monitor has written. So that packet scoreboard will read, so it has to say dot get. So that packet is read by the scoreboard via the mailbox, and then it checks whether the packet's sum, which is tr.sum, is evaluated properly. So it sees whether this is equal to a plus b. Okay, it manually separately does that evaluation. So if they do not match, then we get to know that DUT has not done this evaluation correctly. So I just print the message as mismatch. Else I'll say that this test has been passed. Okay, so I'll just display $display pass. So end task, end class. That's about the scoreboard. Coming to class environment. So this is the entire test bench outer layer of all the components, right? The environment holds everything together. So class environment, we have driver, we have monitor, we have scoreboard. So I have just instantiated one instance of these components. And then mailbox, we have two mailbox, one interacting between, one is the mailbox interacting between generator and driver, and one more between monitor and scoreboard. Then we have this interface, which we have to declare as virtual because we are in the class environment. And then in the environment class, we'll be building all these things by calling a new function. It's a constructor. So when I call the constructor, I'm actually allocating memory for these components, right? So gen to drv, is new. That is, the mailbox has been instantiated. So I allocate space for that mailbox. Then mon to SCB, that is one more mailbox is also allocated with memory. Then we have driver allocated with memory, monitor allocated with memory, scoreboard is allocated with memory. And we are also connecting the virtual interface to the static interface, that is dynamic to static interface. We are making these connections. So drv.vif is getting connected to VIF, right? So this VIF is getting connected to drivers VIF. Then we have these gen to DRV and MON to SCB. So this belongs to, this has been declared in driver. So drv dot gen to drv is gen to drv. Then mon dot mon, it's, this is in monitor, right? So I'm connecting mon to scb to mon to scb. So all these connections we are doing. Okay, we are we are calling the constructors of these, and we are making the connections. So that's about the function void build inside class environment. Then we run all these components inside a task run. We use fork and then join none. It's not a fork join, but it's fork join none. The reason being, I want all these to run parallelly, independently of each other. They need not uh, wait for sequential execution and then make the other statements execute after them. So I don't want such things to happen here. So I'm just using join underscore none so that everything will run parallelly without waiting for anything else. So that's about all these components, how they have been written with their own different tasks required inside their classes. Then coming to module test. So that's the outside the environment. We have test, if you remember this block diagram. So we have test outside the environment, which holds all the entire test bench environment of system Verilog. So we do here is, that's the module. So I name it as module test, and I invoke environment inside it. Okay, so uh, and then I call the constructor of environment. So E is equal to new. Then what I do here is I connect the interface, the static interface, with the dynamic interface. E.vif is equal to INTF. So INTF is the static interface which gets connected with the dynamic interface. Then you just do E.build, E.run. When I do E.build, I'm actually allocating a memory for all these components that gets invoked. E.run will invoke all the classes. They run parallelly. And then what I also do is 10 different samples. I generate 10 different test cases using repeat of 10. And by taking transaction packets, transaction tr is new. So every time I'm calling the constructor of transaction, so one object of tr gets initialized. And then I generate a I call this tr.randomize. When I call tr.randomize, since transaction class has rand bit 3 down to 0 a comma b, this one. So if you observe here, we have rand bit 3 down to 0 a comma b. So this gets enabled when we call the built-in function randomize. So I have called the built-in function randomize here by saying tr.randomize. So I'll get 10 different test cases for AB because it's inside repeat of 10. Okay, and these test cases, every time the values of A and B generated are, we put it in the mailbox, gen to DRV every time. So mailbox gets 10 different test cases of the transaction packet, which is then given to the DUT via interface, and DUT evaluates the expression sum is equal to a plus b with these 10 different test cases, and the result it puts on the interface, back onto the interface, and from that interface it goes to the monitor, and from monitor to scoreboard, wherein the scoreboard actually checks whether the DUT has done proper evaluation, right? And if it has done, it it displays the answer as pass. Otherwise, it displays the answer as mismatch, which we have written here inside the class scoreboard, right? So this is the DUT for that. well. And so what we do here is we have module top, and in this module top, we actually invoke the interface, we invoke the DUT, and then we also invoke test T1, this test T1. This test T1 is invoked here, which in turn invokes environment, and which in turn builds and runs the environment, and uh, hence in parallel runs all the components parallelly with this fork join none, and randomly generates 10 different test cases which have been evaluated. So this is the way the test bench environment is used to verify a particular DUT. And in this case, it's a DUT written for a 4-bit adder. Okay, so that's it about part 4 of interface in System Verilog. Thank you very much.